Hi, and welcome to the video on the SI measurement system. Okay, today we're going to talk about the International System of Units. Basically what this is it's the metric system. It's just basically consists of 7 base units, and you guys have seen these before, right? You have seen, you've seen the meter, right, for length, you've seen the kilogram, and you've seen the second. These other ones right here, this one's more about physics, chemistry, things like that. So we're not really going to use those. We're going to use mostly these 3 right here. It's the most widely used system of measurement, and the United States is the only industrialized nation that does not adopt the SI system or the metric system. Okay, so like I said, it's often referred to as the metric scale. Okay, and prefixes indicate an integer power of 10. So basically you start at the, let's say, the gram. Okay, so if you have deca, that's 10 to the first power, which equals 10. And then 10 squared is the same thing as 10 times 10, which is 100. And then 10 to the third is the same thing as 10 times 10 times 10, which is 1,000, so on and so forth. And over here, on this side right here, you're getting smaller. So 10 to the negative 1 is the same thing as 0.1, or 1 over 10. 1 to the negative 2 is the same thing as 0.01, which is the same thing as 1 to the 10th times 1 to the 10th. Okay, so basically on this side, you're multiplying, and on the other side, you are dividing. So this is getting bigger, and this is getting smaller. Okay, so really what you need to know are these prefixes and what they mean. Okay? All right, so this is just showing you, common size comparisons, just kind of showing you the difference between 1/10 of a millimeter as opposed to 8/10 of a millimeter. So you can see as the number gets larger, right, then obviously the diameter is going to be larger. Okay? All right, so a measurement always includes a value, right? It always has a number, so it's got to have a number. So it's got a value of, let's say, 10. It has to have a unit. So unit means something like 10 centimeters or 10 feet, okay? And the other thing that it involves is uncertainty. Okay, that just basically means that whenever you're measuring something and it's not exactly to the line, like exactly an inch or exactly an inch and a half, there's some sort of uncertainty involved. So you're going to have the best estimate of that quantity. And when they're doing that uncertainty and using those measurements, they use something called significant digits. Okay, a significant digit is basically digits that are in the decimal side of a number. Okay, whenever you record a measurement, it's called a significant digit, and we're always going to include all of your certain digits and then one of the uncertain or estimated digits. And we're going to talk about that here in a second. Okay, so general rules, digital instruments, and we're not really going to use these in class, but that'd be kind of like a calculator, or if you had a digital scale. Basically, it's saying you're going to read and record all the digits, including the zeros, after the decimal point, and display exactly as it's displayed. Because if it's doing it digitally, it's telling you the exact measurement, and it's doing that rounding for you. What we're going to be using is a decimal scaled instrument. So that would be something like a ruler, a protractor, and the other item that we're going to be using later this week is called, or actually later next week, is called a caliper. It'll become your best friend. Okay? A ruler, you guys all know what a ruler is. When we're talking about metric scale, remember we're talking about centimeters and millimeters. So every ruler you see for the most part is going to have a little over 30 centimeters on a graduated scale. Graduated means that it's been changed or it has indications for something smaller than that, which is 10 millimeters. And what that means is that if you're looking at a ruler, 1 millimeter is going to be your smallest increment on that ruler. When you get to the next one, then this would be 2 millimeters. This third one would be 3 millimeters, 4 millimeters. Okay, so the next one after that, and you're going to have 5 millimeters. Okay, so there are always going to be 10 increments within the metric scale because it's on a base of 10. So that's our second benchmark, right? It's our half mark, not our whole centimeter. Okay, these are the only things that are actually marked with a number, and this is something that you should know: is 1 centimeter is equal to 10 millimeters. All right, so we're going to use the decimal scale. This one's asking you how long is the rectangle, and the rectangle we're talking about is obviously that one. So they're giving you a little bit of a closer look. So first thing you want to look at is what is that number in between, okay? So we know that it's in between 3, because it goes over 3, and it's in almost at 4, but it's not quite at 4, okay? So then you look at our other benchmarks. So we have this benchmark right here. So at this point, we know that it's 3.5 centimeters, okay? So then you just start counting. So we've got 3.6, 3.7, 3.8 right here, and then this one is 3.9. So it's between 3.8 and 3.9. Okay, then you have to look, all right, so is it halfway in between 3.8 and 3.9? That's where the uncertainty part comes on. Okay, we know it's not exactly 3.9, so it's going to be 3.8. And then if you look where it lines up, right there, okay, it's a little bit less than halfway in between 3.8 and 3.9. So if we were going to estimate it, we would give it 3.84. And this next slide is going to show you a little bit better. Okay, so that's what they're looking about. They're talking about this one first, in between 3 and 4. Okay, so we know it's at least 3 centimeters. And then we know that it goes to here, which is the 5, 6, that's the 3.8. And then you have to look at where does it actually lie in between there. And that's the 3.84. That'll be centimeters. Okay, so the best estimate is going to be 3.84. Okay, so these first two numbers, the 3.8, those are certain numbers because we know that it crossed over 3.8. And then this one right here is our uncertain digit, right? Our estimated digit. Okay, so this one we're looking at the same thing. It says that it's 6.33, so we know that it's between 6 and 7, so that's where we get our 6. Okay, then it goes, this is 1, 2, 3, so we know it's 3. Then we look at hangs over. It's not exactly halfway, it's closer to the 6.3 than it is the 6.4. So you would estimate here, they're telling you that it's 3. Now if you estimated 6.32, it wouldn't be wrong, but if you estimated 6.39, that would be wrong. You have to use your best guess in using the knowledge that you have. Okay. Thing you have this in your notebook, what you're going to do is you're going to go ahead and measure each rectangle using as many significant digits as possible. Remember, you're going to have at least 2 certain numbers, and then that third one's going to be an estimate. So in your notebook, you're just going to make a table of A, B, C, D, and E and record those measurements. Okay, go back and watch if you have any questions. If you need to ask me any questions, please feel free to do so. Have a good night.